Okay, so last time we talked about computer programming, we were talking about what are integers. And then so we were saying that integers are counting numbers, like 0 is a integer, right? 1 is an integer, maybe 1, 2, 3, 4, 1,234. Now, what if I go like this? 1,234. Is that an integer? Well, the comma in there kind of changes things and it makes it more like a string. So the reason why we need to talk about what a string is because in computers, like if the data types matter, okay? So if I'm saying like the word frogs, okay? Frogs. The computer's not going to really know what that means in code usually. It might think that frogs, it might be like, okay, what's frogs? Is frogs is that something that you're storing data in? What's frogs, you know? And then so you might be able to say something like var frogs equals ribbit. And so what does that mean? That means in JavaScript, a variable named frogs is now been assigned the value of ribbit, R-I-B-B-I-T, ribbit. So what does var mean? Var just means this thing over here is a variable that can have value assigned to it. In this case, the quotes means that we're looking at a, we're going to zoom in here so you could see better. How's that? There we go. Ribbit. The quotes around it means that it is a string, okay? Now, in JavaScript, if I say frog in quotes, or you can even sometimes say like cat in the kind of single quotes, that's okay. But in Java, so there's JavaScript and there's Java. JavaScript is like for making websites and stuff. And then Java is a more strict data type that has been somewhat replaced by C# lately, but people still use it and it still has a lot of value. And it's nice because each data type is like strict. JavaScript and Python doesn't stress out too much about your data types as much, but it's good to know it. So let's kind of just go through this one at a time. So let's just say what an integer is, integer, and let's put some examples in there. I'm going to just do an error. Okay, testing 1, 2. So let's think through this here. So we got an integer. What is an integer? Okay, so let's go. Let's make some thing here. Data type. Okay, and then we're going to say what it is. And then example. Okay. Okay, an integer, I'm going to say counting number. Okay, let's give ourselves more room. Counting number. I know, we'll make it like a chart. Integer, counting number. There we go. And I'll just say 0, 1. Actually, I'm not going to do comma. 0, 1, 4, 1, 2, 3, 4. Technically, an assigned integer is possible too. And then I'm going to say mystery. I'm going to say the letter A. And we're going to get back to that. Why would it be a mystery of the letter A? That doesn't make sense. We're going to get back to that. And then we're going to say signed integer. This chart is having trouble. View, zoom out. Signed int. We'll say int. Int means integer. Integer / int. Okay, this chart's not that good here. Okay, and then this one's going to be we int, but we can for sure know if it's negative or not. So what this is, let's just kind of make it more like this chart like this. So, and then, yeah, we're going to just pull the examples down here. There we go. So you get the idea. That's a little bit better. We got more room. And then some example would be -1, 4, 4, 4, 1, 2, 3, 4, you know, like 8, 8, 4, 8, 4. And then we're going to say unsigned int. Now this one's different because we could say 0. We could say 1, 2, 3, 4, 5. We could say 40, 33, 33, 40, 4, 4. You know, those are fine, but it does, none of them are negative. So unsigned ints, it's not going to store the data in the bits that we were talking about before for knowing if it's signed or not. Now here's something interesting. Now we're going to say char or character. Now in Java, a char or character, char, would be something like this, a. Now a, I thought a is an int. Well, here's a really weird thing. In Java and other languages, okay, chars have an integer value. So it's called ASCII, Unicode. All these things have values. So like, let's say this a and a lowercase a are different. Char, they're characters. Okay. If I go like this and I say like, this is, there we go. Usually letters or single symbols. And so remember how we said there was binary and then there were assembly code? Well, how do you make a word, right? Well, you make a word out of letters and characters. But the computer needs to know how to create that letter A. So how are you going to do it? Well, you're going to do it out of making integers to do it. So we look at, let's say we're in Java and the computer's looking at like the char of A and then the char of C and then the char of A and then let's see, A, B, C, U, V, W, X, Y, and Z. So what is that? Q, R, S, T, U, V, W, X, Y, and Z. That is 4 plus 2, which is 6. 26 letters in the alphabet. So I'm probably guessing that if, oh yeah, A has an integer value in Java, A roughly correlates to the integer of 65, usually 65, 66. I'm pretty sure it's 65. So there's 26 letters in the English alphabet. If we want the letter T, We'll subtract 6 from 26, so that'll give us 20. Okay. The letter B is going to be 66. C is roughly 67. And T should be, let's see, 26 plus 65. Let's say 26 plus 65 is 80, 91 minus 6, because we got to go back 6. So let's be about 85. Okay, so T is 85. So now we have ACAT, a cat. Chars. Words are made out of chars, words, and words are generally made as strings. So a cat is made out of the char of A, the char of C, the char of A again, and the char of T. That's roughly giving you an introduction to chars versus ints. Ints create chars. And in ASCII, the most basic character language, that most basic way of looking at characters, that kind of code. Later, they came up with Unicode, and which has even more chars in it. Look, you can even have a char of a tilde could be a char. Okay, a char of an at symbol, char of a z. Okay, those are all different chars. I'm gonna make my head smaller. Oh, okay, char of a z. Okay, so let's look at our program here. So this program makes a function, compute result. That's primarily what we're looking at. Let is kind of like var, but it's block level. Usually people use let more often than they use var. Okay, there we go. Make this a little smaller so I can make my head bigger. Bibbidi boo. Okay, so let's see what happens if we run this program here. JavaScript. Okay, I'm going to enter some data, and my data is going to be puppy. And I submit, and the result is frogs. What does puppy have to do with frogs? Like 12. Let's just refresh it. I entered 12, and I hit submit, and it says frogs. This has got to be the worst function in American history. Frogs is like whatever you do, the function says frogs. That's kind of boring. Let's take a look here. Compute result. Let result equal frogs. Okay. And then the output, where it's kind of like result, this text is going to be whatever this let result is. Let's verify that. Oh, there it is, output. Paragraph result, output. Okay, the output is going to be whatever result is. Can we change this? I'm going to call this function result. Save that. Refresh. Now it says function result. And then if I say 4412, it still says frogs. Okay. So how can we make this a little bit more exciting? Well, it seems that this text context is always going to be frogs. So then let's change it. Let's change it. Froggy and a donut. Save that. function result. Let's refresh that. And I'm going to type in 1, 2, 3, 4. And I submit. And it changes it to Froggy and a donut, which is pretty cool. But like my input doesn't really affect anything. Okay. So a function in JavaScript, the purpose of a function is usually designed to do work so you're not having to retype everything. And when you think about it, this function is doing the same thing every time. And it's, you know, it is saving a couple lines, because when you think about it, this line of the output is pretty cool because it's doing some work. But in general, it's not really, you see this input is like the input field value. Where's the input field here? Okay. You see where it says enter data? Let's change this to say enter a type of donut. Save that. Refresh. Enter a type of donut is the suggestion thing. So let's just say type of donut, glaze. And we hit submit. Froggy and a donut. It's better, you know, but it could be better. I think this program could be a little better. So we want to get this input connected to the output. Okay, we have the input. It's whatever I type. But let's verify that. Let's verify that. Let's say console.log input. And actually, we're going to go here. Console.log. Every time this function results, we're just going to say inside compute result function. Just so we kind of have an idea of what's going on. Save that. We're going to refresh. And I'm going to say cruller. Submit. Okay. Inspect. Console. Do we have an error here? Cannot access input before initialization. Uh-oh. Let's see. Input. Input. Okay. So it can't read that input field. So let's change that block code and put it inside the hole. Let input equal, First thing we're going to do is we're going to log a console.log this, that we're inside our compute result function. And I'm going to say here console.log, the value of the input variable is below. And then, oopsies, I'm going to go like that. And actually, I'm going to change input. I'm going to give it an underscore there so I know it's a temporary helper variable. And I'm going to do the same thing with result, just so I kind of have an eye on it. Let's see what we get. Refresh. Close. Oh, I don't want to close it. Go like that. Enter a type of donut. And I'm going to say cruller. Submit. Okay. Now we have some information. Inside compute result function, the value of the input variable is below, cruller. And it says function result, froggy and a donut. We're not using cruller though. It would be cool if cruller was used in our program. So we got index.html. We now can access the input. That's good. But what we want to do is make it so it's interactive. So what do you think we should say? What if we said it was like we enter a donut type and it says like, I got an idea. We're going to say the donut we're going to kind of leave a space there, plus input donut costs, I don't know, it costs $1.49. It's not too expensive. The input donut costs $1.49. Let's see what happens. Okay, Froggy and a donut. We refresh. Enter a type of donut. Eclair. Submit. The eclair donut costs $1.49. Whoa! This is getting pretty good. What do you think? The eclair donut costs $1.49. That is pretty cool. So, what if... Okay, I'm liking this now. I'm liking this program now. So what if we go here and we go var price equals... Oops, we're not going to put in... We're going to make this one a float. 1.49. Oh, what is a float? Oopsies. Float is a... you could think of it a number with decimal precision. An example would be like 1.49, 0.894, 0.000, you know, that kind of stuff. Just so you get a flavor for it. Oops. I'm not going to save that right now. Okay. var price is $1.49. Donut costs, get rid of that. The input donut costs $sign plus price. Save that. And let's lower the price to $1.39. So the price, let's see if we can access price. It's more of a global variable. So I would expect price to be accessible from within this script. Submit. Let's see if it can. If it can't, it's no big deal. We'll stuff it in there. I don't have a problem with that. So we're going to say declare again. Submit. Oh, the eclair donut costs $1.39. That's kind of cool. And now if we say let price 2 equal $1.59, and then let's say price 2. Remember we said that oopsies. Remember that we said that I'm gonna make my head smaller so we got more room. I'm gonna move myself over here. There we go. There's block scope. I think it's gonna error out because we're using a let instead of a var, but let's see, maybe it'll work. Maybe it'll figure it out. Refresh. Crueler. Can I hit enter? No. Submit. The variable is $1.59. I guess I can read it. Price, input. I guess it's getting the scope in there, so it doesn't have a problem. But, you know, it's like price 2. How do we know what's what? This would be better if... Let's make... I got an idea. Let's keep the names of the... What can we do? Let's keep the names of the donuts that are available in an array. So an array can store data points. So let's say let available donuts equal an array of crueler. Let's do them in all caps, so you got to spell it like crueler. Declare. And then We need one other donut type. Cooler. Sprinkles. 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 Okay. Sprinkles. Okay. Now, down here, JavaScript output. Enter a type of donut. Yeah, it's not going to know body script placeholder. It's not gonna have that accessible. So we're not going to worry about that. I know, I got an idea. We're going to go, when this program even runs, let's let it console.log this. So we're just going to have this in the available donut names are below. And we're not going to worry too much about it. Well, I'll show you guys more advanced stuff later. But I mean, this is just a fun first day here. Console.log available donuts. So normally you'd want to have a sign or something that shows this, but I'm more concerned about you seeing it in an array than it being visually juicy. So, okay, bam. I just refreshed it. I haven't submit yet. Available donut names are below. Cruller, Eclair, Sprinkles. Fine. That's good. Now what we're going to do, we're going to say let prices equal let prices equal, and actually let's make it an associative array, kind of like that. And then let's say Eclair, oops, we're going to go cruller. It's going to be 1.49. Eclair 1.39. And sprinkles is going to be 259, a little bit more. Let prices equal that. Let's just console.log the price data is below, just to make sure we structured it correctly. Console.log prices. Oops. Prices. Let's just see if this makes any sense. Refresh. Okay, I like this. The price data is below. Cruller 149, Eclair 139, Sprinkles correlates to 259. Okay, it's just data. It's not a big deal. So what can we do? The input variable is below input. Okay. What we're going to do now is we're going to say let lookup equal prices at the index, or prices at the key of input. And then we're going to say if lookup is like undefined, or lookup equals null, or lookup is equivalent to, equals means is equivalent to, loosely, I'm going to scroll down so you can see that better. Lookup equals, let's say null, undefined, or empty string. Then we're going to just say, you know what? Let Actually, you know what we're going to do? We're going to define let result up here. Let result equal price. Just so it's like this rough thing. And then we're going to say result equals sorry, the donut is not. Sorry, the donut you're looking for is not on the menu. Something like that. And then we're going to just copy this. Well, actually, let's type it out. Document.get element by ID output. It's much easier to learn coding if you type it out. Text content equals result. I'm going to separate this so it's very clear what's going on. But what we're going to do here, we are in a function, which is nice. So what we're going to do is we're going to do what's called a exit the function by a void return. So we're going to exit the function now by just saying return. Nothing else is going to get done. And then, you know, it's going to give us that issue. So let's try it. Refresh. Uh-oh. Result's already been declared. Let's take a look. Let result equal price. Oh, let result here. That makes sense. So we've already defined the result here with a let, and it's a little bit more strict than a var. So I'm going to just save result here. Redefine the result. Okay, so we're just actually it's more like reassign. Okay. Sorry, this is not on the menu. Let's see what happens here. Refresh. Okay, no errors. That's good. Enter a type of donut. Let's put a donut that's not a cruller, eclair, or sprinkles, okay? Let's do sprinkles, cream filled. See? Function result. Sorry, the donut you're looking for is not on the menu. Okay. Will eclair work? Eclair. E-C-A-I-R. Eclair. The eclair donut costs $1.59. But that's not correct. It's decent, but that's not correct because an eclair we know is $1.39. We're getting overcharged. So how do we make it so the price relates to what we put in price is? Well, what we're going to do is say let lookup equals prices at input, let result equal price, reassign the result, result equals $, but lookup. The input donut costs lookup. Let's try it. It's looking it up in the table. It's looking it up in this little associative array that we made. And in JavaScript, you could also call this kind of like an object because it's got these curled braces. This is the beginning of learning JSON or JavaScript object notation. This is a very rough introduction to it. We refresh this. Double check, make sure things are working correctly. We said the donut of, let's say, chocolate. Enter. Oh, that didn't do anything. Submit. Sorry, the donut you're looking for is not on the menu. That's fine. Let's say eclair. Submit. The eclair donut costs $1.39. Eclair's $1.39. That's correct. Let's try sprinkles. Sprinkles. Submit. The sprinkles donut costs $2.59. Wow, that is so much better than having to type in a separate price for each one, right? We just did it once. It accesses the associative array, and it does work for us. Cruller. The cruller donut costs $1.49, which is correct because that's what's in our array. So, or associative array. Also, some languages call a structure similar to this called a dictionary. It just depends on the language you're in. But I know this is a very rough introduction to functions, but it's good to jump into functions and have fun with them because it's a lot more fun to work with functions and data structures and everything. This is called a very basic data structure. And we did it. This is pretty good. Now, is there any, can we clean up anything? Do you see this var price and price to? We're not really using that anymore. Let's just double check to make sure. We have price, but that's just a string of price. It's not actually accessing the variable. So I think we can get away with cleaning that out. Save it. Save. Refresh. Type in a donut. Let's just say frog. Sorry, the donut. There's no frog donut. Okay, good. And then let's say cruller. The cruller donut costs $1.49. Yeah. So we no longer need that hard-coded price and price to. But we do need this prices data structure. And my name is Tyler Stansfield Jaggers, and for watching another episode of Kansas Now. I hope this was a fun one, jumping a little bit more into data structures, which is important for, going beyond just. It's one thing just to know a data type of a piece of information. It's another thing to store a structure. So I think that's a good start. Have a great night.